right, so in this example, we're going to look at an experiment that was run related to infant attachment. So mothers were randomly assigned to use either soft baby carriers, which promote more physical contact, or plastic infant seats, which would give you less contact, to carry their babies. And then they used the Ainsworth strain situation to figure out what type of attachment the babies had formed. So this is a protocol where researchers observe babies and their mothers as the mother comes in and as the mother leaves and as strangers enter the room and things like that, and they see how the babies respond. Okay, so we're looking at the explanatory variable is the type of baby seat, so that was randomly assigned. And then the response is what type of attachment. And we're treating this as just secure or insecure, so putting them into two categories for the response variable. And that's different from everything else that we've done this semester. We've been looking at quantitative responses. Now we're going to be looking at categorical responses in this chapter. Okay. So let's say we wanted to decide whether the type of carrier made a difference. We would want to calculate for each group what's the proportion with a secure attachment. So in the soft baby carrier group, it was 0.8261, and in the plastic carrier group, it was 10 out of 26, so 0.3846. Okay? The graph that we're going to use, there's actually multiple types, but by far my favorite graph for this is called a mosaic plot. So a mosaic plot starts off by splitting the axis based on the sides of the groups. So these groups are not exactly the same size. The soft baby carriers had slightly less than half, so you can't really tell here, but I'm going to do a little slightly less than half for the soft side. And then you divide it again based on the response variable. So for the soft carriers, we'll put it up here about 82%, and then for the plastic carriers, maybe down here. So this is the secure attachment that I'm marking here. So because these two proportions are different, we would say that there is an association between the type of carrier and the type of attachment. So on the rest of this page, we're going to talk about a couple different ways to describe the strength of that association. So maybe the most obvious way is just to calculate the difference. So we're going to do the proportion in the soft group minus the proportion in the plastic group. And these are called conditional proportions. And that's because you're calculating the proportions within each group. So what's the proportion of secure attachment under the condition that the baby was in a soft carrier? What's the proportion under the condition that they were in a plastic carrier? Okay, so we're taking the difference of those conditional proportions, and we get 0.4415 is our difference. So to interpret that, we would say that the proportion who formed a secure attachment in the first group, so in the soft carrier group, the proportion who performed a secure attachment in the soft carrier group is this much higher, 0.4415 higher, compared to the plastic seat group. So notice that this is really explicit. It's comparing the proportions, and it's really explicit about what the two groups are. Okay, you do have to be a little bit careful when you talk about the difference of proportions, because it would not be appropriate to say 44.15% higher. If you say that, that sounds like you're multiplying them, right? That you're taking the smaller one and multiplying it by 1.44. So we don't want to say that. We wouldn't want to say 44.15% higher. We want to make sure that it's really explicit as a difference of proportions. Okay. Another way that you can do it is you can look at the relative risk. So here, instead of subtracting them, we're going to divide them. Okay, so we do I've got the first group on top here. It actually doesn't really matter which way you go as long as you interpret it in a way that matches. So here I would say those in the soft carrier group were 2.148 times as likely. So now we're comparing them by a ratio instead of subtracting them. 2.148 times as likely to form a secure attachment. And again, I want to be explicit about what I'm comparing, compared to the plastic seat group. Okay, so we've got two options so far, a difference of proportions and a relative risk. So those are essentially telling you the same thing, but psychologically they can have sort of different effects. So for example, imagine that the probability of contracting a certain rare disease is 0.005, and if you eat a cup of blueberries every day, you'll reduce the probability to 0.001. Which of these do you think would make the impact of the blueberries sound more impressive? The difference of proportions or the relative risk? Pause the video for just a second and decide which would be a more impressive sounding statistic. So if you calculate the difference of proportions, you're just going to subtract them and you get 0.004. So basically the proportion of people who contract the disease would go down by 0.004. That sounds like a pretty small impact. But let's think about the relative risk. Here, if we did 0.005 over 0.001, we would get a relative risk of 5, right? So in other words, those who don't eat blueberries are 5 times as likely to contract this disease. 5 times as likely to contract the disease. That sounds a whole lot scarier than saying that your risk, your probability of getting the disease has gone up by 0.004. So neither of these is necessarily wrong, but we do need to be aware that people will react differently to the two statistics. So just to give you an example that's a little bit more realistic maybe than the blueberries, the World Health Organization has classified processed meats like ham and bacon as a group 1 carcinogen, the same class as cigarettes. So you may have heard that, and it is true, but it's a little bit misleading. The average risk for Americans getting colorectal cancer is 5%, and the relative risk for someone who regularly consumes processed meat is 1.18. So that means that their risk is about 6%, right? It's gone from 5% to 6%. But a lot of times you'll hear this reported as an 18% increase in risk, right? That's not wrong. You just have to be aware that they're talking about the relative risk, not the absolute change in risk. So we've talked about two options that we can use to describe the strength of the association. There's one more that we're going to talk about that is very similar to the relative risk, except instead of using just the proportion, it uses the odds ratio. So we have in the numerator here, this is the odds of the secure attachment in the soft group. And then in the denominator, this is the odds of secure attachment in the plastic group. So you may not be too familiar with the idea of odds, especially if you don't gamble a whole lot. But the idea of odds is basically a ratio of successes to failures. So you can see like we've got proportion, that'd be like the proportion of successes, and then 1 minus the proportion. So that'd be like the proportion of failures. So you do see this when people are talking about gambling. So like the betting odds for Tiger Woods in the Masters were 14-1. So that means we'd expect 14 losses for every 1 win, right? There's a ratio of 14. In this case, they do it failures to successes, 14 failures for every 1 success. So that's sort of how you think about the odds. All right, so let's calculate the odds ratio. So we'll start with the odds of secure attachment in the soft group. So in the soft group, 0.8261 is the proportion of successes in the soft group. And then if we do 1 minus that, we get 0.1739. Okay, and then if we do successes in the plastic group, it's 0.3846. If we do 1 minus that, it's 0.6154. So if we put it together, 4.7504, that's the odds of a secure attachment in the soft group, whereas 0.62496, that's the odds of secure attachment in the plastic group. And we can put it together and get an odds ratio of 7.545. And the interpretation of this is very similar to the relative risk. So we would say the odds of secure attachment in the first group, so the odds of secure attachment in the soft group, were 7.545 times as high, so you can tell this sounds similar to a relative risk, as the odds in the plastic group. So if these interpretations are similar, and odds are definitely harder to understand than probabilities, why would they ever use an odds ratio instead of a relative risk? So it turns out there's actually a big issue with relative risk. So let's say that we redefine what we call success, and instead of counting the secure attachments, we're going to count the insecure attachments. So in the soft group, here's our proportion, in the plastic group, here's our proportion, and we calculated the relative risk, and we got 3.538. So that's a bigger number. That makes it look like we have a stronger association now than we had before. But of course that makes no sense. The data hasn't changed, so the strength of the association hasn't changed. Another problem comes if you try to switch the explanatory and response variable. So here, let's say that we were saying of those with secure attachments, how likely were they to be in the soft group? Of those with insecure attachments, how likely were they to be in the soft group? If you do it this way, we get yet another relative risk. So again, we've got the same data, but we've calculated 3 different numbers for the relative risk. So the big advantage of the odds ratio is that this doesn't happen. The odds ratio doesn't change based on those 2 things. So it doesn't change based on how you define success and failure. So that was one thing that messed up the relative risk. Doesn't change based on how you define success and failure or explanatory response. So you can still get a different number based on what number you put on top, but that's just going to be either this or 1 over this value. So those are pretty easy to translate back and forth.